In today's video, I'm going to explain how to graph sine, cosine, and tan. The parent graphs first, later on the different type of sine functions, cosine function, and also tan functions. So to understand all three, let's first start with the parent graph for sine. Usually our function for sine going to be f of x equals, as you see, a sine bx. Each of them have a different job that doing for the graph. So dear students, domain, as we know, is a set of all input values for the function. So here we have no problem with any number, that's why domain going to be all real numbers. About range is always depend on this number here. So going to be from negative of this value that you see here till positive of the same value. So this is going to be our range. X-intercept going to be this value that you see with x equals n pi, where n is an integer number. About y-intercept for this type of function is going to be 0, 0. And amplitude is about to find out is the same as absolute value of the value of a. And period going to be 2 pi all over absolute value of b, because the values must be positive. What's the job of period or amplitude? Amplitude telling us the range, and the period is about until when this, because we know that the trigonometry functions, they are periodic functions. So the graph of sine usually 1 period 360 is something like this. So after how much we will have full cycle or 1 period, because you know that trigonometry is about circular graph. Okay, let's apply all of these for parent graph. If we have f of x equals sine x, we know that our domain is R, our range is depend of this number is between 1 and -1, and our x-intercept x equals n pi. So if we pick some values for n, we can say, let me just erase this one, we can say if n equals to 0. So if n equals to 0, then x equals 0 times pi, which is equal to 0. If n equals 1, input 1, so x equals 1 times pi, and the value equals only pi. How about when n equals 2? So going to be x equals 2 pi, right? Same values we can get if we substitute negative values. So that x-intercept means where this graph passing through x-axis, this is the x-axis, passing through 0, through pi, 2 pi. And also from the negative side, negative pi and negative 2 pi. Okay, there is another important note, which is the value for pi over 2 and 3 pi over 2. We know that the value of pi over 2 equals 1 in sine, and value of 3 pi over 2 equals -1. And also value of negative pi over 2, which is 90, equals -1, and value of pi -3 pi over 2 equals 1 if you're writing calculator. Then we will just join all of these points together. By joining them, you will get this graph. This one, something like here. And also from the other side, you will get the same. And this one, by the way, from both sides, continuing. Dear students, we have an example. In this example, saying graph f of x equals 3 sine 2x. So in this example, first we should find out domain, range, x-intercept, y-intercept, amplitude, and period. Then we can find the graph, or we can graph easily by using all of these informations. Okay, let's start with domain. We know that domain for sine, this normal sine, going to be all real numbers. Our range, we say that is depend of this value in front of sine, so the value going to be from -3 until +3, because the amplitude is going to be absolute value of 3, which is equal to 3. Okay, how about x-intercept? We know that x-intercept, we say that usually x-intercept equals n pi, but here the value is 2x, so we should say 2x equals n pi, then divide by 2, cancel this one, so final answer x equals n pi over 2. Okay, dear students, you can pick values for n in order to know your x-axis values or x-intercepts. If n equals to 0, so if you substitute 0 here, 0 times pi divided by 2 equals to 0. When n equals 1, if you substitute 1 here, going to be x equals pi over 2. So in this case, pi over 2 become x-axis, but in the parent become x-intercept, but in the parent graph, pi over 2, it was not x-intercept. Okay, let's pick these two numbers. The rest, if we need it, we can pick more. Y-intercept going to be 0 0, because when you make y-intercept is about x equals to 0, right? When x is 0, so 3 times by sine 0 equal to 0, so y equals to 0. Okay, about period, we will divide 2 pi by 2, right? Okay, then 2 pi divided by 2 cancel, because 2 is about b here is 2, so final answer equals pi. So that we can pick one more number when n equals 2, so going to be x equals 2 pi divided by 2, so x equals pi. So pi going to be the one period for this graph. So our x-intercepts, we can plug these values on the coordinate on the x-axis. So we have 0, I already wrote 0. Then let's write down the other one. Let's change the color to red. We have pi over 2. This is pi over 2. But let me extend a little bit more to the other side. This is pi over 2. And the other one is going to be pi, right? Because these are our x-intercept. Same values with the negative. So going to be negative pi over 2. And the other one is negative pi. Okay, graph of sine, we say that starts from 0. And also something important you should not forget, our range is from -3 until +3. Remember this one. Okay, as we found. Okay, now you can graph. The graph starts from 0. One period going to be until pi. So the graph starts waving until pi over 2. Then from pi over 2 goes down until -3. Then passing through pi, like that. From the other side the same. It goes until -3. And it goes up, but this is very bad. Because we are not on this scale. It's not drawn on this scale, that's why it looks like that. But anyway, should pass through these values. I know it's not perfect graph, but this is how you will graph. Okay, students, right now let me explain second one, which is cosine x. cosine function. Cosine is similar to sine. We have so much points in common, which if you have this value represent amplitude or responsible for range and amplitude, and also value of b was for period. Okay. Domain for cosine, since is not in denominator under square root any blah blah those stuff, so we can substitute any values for this function. We have no problem. So domain here for this function going to be all real numbers. Range again same as amplitude since it's absolute value of a, so going to be from negative a until positive a. Range for this function. Period again 2 pi divided by absolute value of b. Y-intercept is different. Since we have y-intercept is about x equals to 0. If x equals to 0 means cosine of 0 equals y, right? So cosine of 0 equals 1. So that we will get the y-intercept for this function is not 0, 0. So it's going to be 0 and the value of a. If your value, if the value of a is 1, so it starts from 1. If it's 2, starts from 2. If negative 2, starts from negative 2. If 3, starts from 3, and so on. About x-intercept, which values going to be 0 in function? If you want to find out, so we should say x equals pi over 2 plus n pi. These values makes x cosine x 0. For example, pi over 2 which is 90, cosine of 90 is 0. 3 pi over 2 which is 270 or 270 again makes cosine 0. So this is in this formula we can get all x-intercepts where n is belong to an integer set. Okay, the parent graph, as we know, the range is between 1 and negative 1, passing through the x-intercept is going to be pi over 2 and 3 pi over 2 for cosine. Also from the other side, negative pi over 2 and negative 3 pi over 2. So the graph starts from 1, be careful, not from 0. Passing through, but let me just write point. Cosine of pi over 2 0, cosine of pi equals negative 1, cosine of 2 pi equals 1, cosine of negative pi again equals negative 1 by calculator, cosine of negative 2 pi equals 1. So let's join all of these points, cosine joining all of these points here, passing, and makes something like U shape. Then the same thing here, passing through all of these points and makes another U shape. So this is the parent graph for cosine. Okay, dear students, right now let's take example. This example says graph f of x equals 4 cosine of 3x. Okay, let's start with domain. We know that domain is all real numbers, so on the x-axis all the way from left and right you have the value for all x's, so we have no problem for cosine for domain. Range is about, as I said, about this value, because this value is the amplitude, so the amplitude since is 4, absolute value of 4 which is equal to 4, so that the range going to be from negative 4 until positive 4. Y-intercept again is about this value which is 0 and 4. Period is about 2 pi divided by b which is 3, so 2 pi over 3 is going to be our period. X-intercept, I told you x equals pi over 2 plus n pi, but look at here, we have 3x, so that you should write 3. Okay, So right now x equals how much? Because we want x. Divide everything by 3. Simplify. X equals pi over 2 divided by 3, going to be pi over 6 plus n pi over 3. Find common denominator to make it easy for yourself. 3 and 6, you can multiply this one by 2 and this one by 2, so going to be this one 6 and this one 2. Okay, all right. Right now pick values for n in order to find out the x-intercepts. So if n equals to 0, let's start with 0. If n is 0, so this part 0, so we get only pi. X equals pi over 6. Second one, when n equals 1. When n equals 1, so going to be x equals pi over 2, pi over 6, sorry, plus 2 times pi over 6. 2 pi over 6, right? Because n is 1 here. So pi plus 2 pi equals 3 pi over 6, right? So final answer we can say 3 pi over 6, which is equal to pi over 2, because 3 with 6 can be cancelled out. So this one going to be pi over 2, right? If n equals 2, as example, if n equals 2, so we will get x equals, we will have 4 pi, so going to be 5 pi over 6. Students, look, this one is in the pattern. Here we have 1 pi, then become 3 pi, then become 5 pi. So next one going to be 7 pi, 9 pi over 6, and so on. Understand? Okay, these are going to be our x-intercepts. So we don't need to write all of them. Remember, 2 pi over 3 is going to be our period. One period is 2 pi over 3. We can write 0. Our x-intercepts, we don't need to write all 3 because it takes so much. So we can pick, for example, we can erase the other one. We don't need it so much. We can pick pi over 6 as example. This one is our x-intercept, and the other one we have pi over 2. So this value 2 pi over 3 is about 135. So 135 is more than pi over 2, it's 90. So we can say until here 2 pi over 3. Why I write this one, even though this is not x-intercept, but this value show us one period for the graph of cosine. Like in the front I graph for you, this is the graph of cosine. So till pi over 2, as you see, this is one period, this is one period. So 2 pi over 3 telling you the period. Even if you don't graph 2 pi over 3 is not big deal. Okay. From the other side we have same values. We have negative pi over 6. We have pi over 2. And also we can write negative, these are negative 2 pi over 3. Remember, our range is from 4 till -4, right? We say that graph starts from the range from both sides passing through these values. And also here, I don't know how, maybe it's bad. Let me just redraw for you. It look like a very bad graph. Anyway, we start from 4. Let me just from the middle to just make a point to make sure that passing through of course pi over 2, pi, negative pi over 2 and negative pi also, and the value between them is negative 4. So the graph is starting from 4, passing through pi over 2 all the way down till negative 4, then goes up and goes till 2 pi over 3. From the side also we have passing through negative pi over 2, then till 4. It's not the best graph, but this is how we will graph. If we have draw on scale, like we have a points coordinates exactly, so we can have better graph than this one. Okay, dear students, third one going to be tan. So here for tan we don't have amplitude and the period is pi. Till pi we have new period every pi, but I don't write here. The most important thing is x-intercept and the vertical asymptote, which is they have a very big role for graphing tan. Okay, first of all, domain for tan, I cannot, let's say, pick every values for tan. Why? Because remember, tan is a rational function, equals sine x over cosine x. So to find out the domain for rational functions, we will set this value to 0, sine x equals to 0. So we just explain it, where the values for cosine equals to 0 when you have x equals pi over 2 plus n pi, correct? So that domain going to be r except these values, pi over 2 plus n pi, where n is integer. It must be integer number. Tamam? Okay, this is about domain. Range, we have no problem, we have no limit about y-axis because range is about y-axis, so range is going to be all real number. X-intercept is going to be same as sine, x equals n pi. How about vertical asymptote? Vertical asymptote, it's the values that makes denominator 0, so it's pi over 2 plus n pi, same as the domain, because vertical is opposite of domain. Domain is r except these values, but vertical asymptote is these values that make denominator 0 for rational functions. So that pi over 2 plus n pi is going to be our vertical asymptotes. Students, x-intercept is going to be, if n is 0, going to be 0, so passing through the graph, passing through 0. If n is 1, going to be pi, so passing through pi. If n is 2, going to be 2 pi, so 3 pi, 4 pi, 5 pi, 6 pi, and so on. And also same values that we have here in the negative, so negative pi and negative 2 pi going to be our vertical, our x-intercepts. Vertical asymptotes, the values that makes denominator 0 was pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, those values when you pick n0, n1, n2 like this. So these values, pi over 2 as example, we will draw dashed line on pi over 2 because makes denominator 0. 3 pi over 2, negative pi, and negative 2 pi. Okay, students, right now let's join all of these by using this color maybe. The graph is going to be starting here from close to vertical asymptote, passing through 0. But oops, we made a mistake. The vertical asymptote should be on negative pi over 2 and negative 3 pi over 2. Okay, now the graph starts from this vertical asymptote all the way passing through 0 and it goes down. Same thing here and also here. This is graph of tan, and always going to be like this as long as we have tan x. But if it's 1 over tan or something, so of course graphs change, which I will not explain in this video. And also something very important, students, only vertical asymptote and x-intercept change if we change these values. For example, if I have tan f of x equals 3 tan x or tan of 4x, right? So here this value changes x-intercept and also vertical asymptote, so that the graph going to be the same, only these values that we see on the coordinate can be changed. If not, the graph going to be similar, the same. I wish you enjoyed. For any questions, please write in the comment below. Thank you for watching till now. See you.